Partha's from today. Very good.
Omkar.
Omkar, sorry. Omkar. Thank you. I just came from. Thank you. Thank you. Peru bhi mein khai, chai bhi piya. I just came. Yeah. Thank you. Yeah. Have you read about the year anytime?
Last year.
Last year. एक में क्या था? हाँ, bio class में था. That's not right. Okay. देखिए, you turn the pages, you will understand which chapter कौन सा है. नहीं है क्या? That part of it is not there at all. What do you mean?
नहीं है उसमें. नहीं है उतना ही है.
You have eliminated this. Arnab, जाके I can ask him to give me a new book, new 9th standard textbook. Anyway, it is interesting to see what is the. चलो हो गया? बंद करो.
हम hand wash करते हैं. हम hand wash से wash.
जल्दी आ. चलो अभी बंद करो. Get something nice to eat, no lace, chips, जैसे get something that's nourishing. What do you have for nourishing? You want so many friends? I don't want so many friends. I'm just seeing if this thing is included in the new textbook. Otherwise, we will need it. That's all. Anyway, I just show it to you because this is the only thing. Applications of sonar is also not there. Yeah. Sonar. No, it's not there. See, I taught you so much about sonar. Which edition is this? This one. 21. Revised edition is 20. Okay, so I'll stick to whatever is given here. Okay. Right. Anyway, since you have already learned about human ear in the East, and just for your interest, we are talking about sound waves. Sound waves is caused due to the vibration of any body. Isn't it? Last time we have already learned. Any object which is vibrating, the sound waves are picked up, and the molecules don't reach. It is the molecules don't reach, it is only the vibrations that come. So this is the external ear.
What's my switch?
Switch it off. Are there? Then you will have to take out that thing inside, and then the button is inside the arms. Yeah. Yeah. I will have to put it. Yeah. That's it. So this is the outer ear. This is the pinna. Okay. So the pinna is the one which is collecting the vibration, sound waves. Then it goes into the middle ear. So when it goes into the middle ear, what happens is when there is a compression and when there is a rarefaction. So when there is a compression, there is a tympanic membrane here, eardrum, that is getting compressed, and rarefaction comes out. So the eardrum is also vibrating. Those fine vibrations is actually picked up by these three semicircular canals. Okay, so this is the inner ear where the vibration is actually picked up. So it consists of the cornea. These are the three semicircular canals. Now remember, the ear is not only for hearing, but it is also meant for balancing. Suppose you are standing on one leg, It's not only your muscles of your feet and legs, but the alignment is also because of these three semicircular canals. Okay, so you have got the cochlea, then you have got the other things are not there. There's an anvil and a stirrup. So these three bones are the ones which is amplifying the sound, and finally it is picked up by the nerve. So which nerve is it? It is the auditory nerve, and then it sends it to the brain. So the brain will interpret what type of a sound it is creating. Which one? Auditory canal is given here. Auditory nerve they have not shown, but it is picked up from here and it goes to the brain. Understood? No? It's just a basic idea of how the ear actually works.
And those ENT doctors, how is it interconnected? Ears, nose,
ENT?
how?
There's a eustachian tube. Did you notice that there is a eustachian tube?
No, bottom right. Miss, so how do our ears ring?
That's it.
Next, we go to the
Top,
right side.
Top right side.
cross.
Bottom,
So cross line. That's
उसका
one.
नीचे
ये वाला
बीच में अरे वो नहीं वो उसका बीच में आपको ये
Structures of the outer ear. This is what I said today. Yeah. Hey, happy Children's Day.
Thank you.
Yeah, 14th November. Can you see this? This is the eustachian tube. Eustachian tube, there is a small tube which is connecting the nose and the ear. Did you notice that when you go by flights,
Yes.
you
When
find
it goes
up, either when you're taking off or when you're landing, some people have a tremendous
you
amount
need to
of,
put the cotton.
yeah, I suffer a lot with that
Yes,
type of a
same.
ears.
When
You
I
know,
was
so what
born,
happens
I was
basically
fine.
is there is this eustachian tube and the eardrum has to be pressurized properly. So if there's more pressure on the eardrum, it gets pressed inside and it is not getting equalized and it causes a shooting pain.
coldness में
Yes, if you're especially if you have a sinus problem or if you have cold or something of that sort, then it can cause a lot of problem. Okay, that aside. Coming back to the sounds that we are going to do a couple of them so that we know, right? Hey, this is your 10th standard classroom. Very soon you'll be all sitting here. 9th standard was that. How does it feel to come back to the 10th standard?
scary.
No? Why should it feel scary at all? Absolutely not. You should be confident now. There's nothing that is so scary about it. There's no lion or anything sitting in the desk.
This classroom has a better camera quality.
Yeah.
I think that classroom was best.
Yes,
Okay. So we have done with reverberation, echo, we have already finished. The range of hearing, also we have finished. Application of ultrasound. Okay, all this is also over. Right? Reflection of sound, speed of sound, everything we have completed. So what we are going to do today is to do a couple of exercises and write down everything. Okay. Then range of hearing, did you write? Did you write? You took your notebook. 20 to 20,000 hertz. Have you
Yes.
mentioned it? You mentioned it yesterday? No.
Yes.
Ultrasound, infrasound, दिखा ना?
Yes, sonar.
Sonar of course is not there. You just put a small cross up because it is not there. Don't cut it out.
Sonar.
Sonar, just put a small cross because it's not there in the new edition.
Oh. Okay.
Okay. Now there's a question which is given in your textbook saying, what is reverberation? Yeah, question number 14. Reverberation.
Oh.
Not evaporation. Reverberation.
NCERT questions or previous year questions.
Have you done the worksheet? I asked you to do the worksheet and MCQ. None of you have done.
Yeah.
See, what is the use? Very cool. I was absent is not an excuse. Reverberation. Okay, so this basically deals with echo. So we have seen that when the sound is being produced here and when it strikes any surface, it is coming back. Okay? What is the minimum distance that is required here? Yes. Okay, because it has to strike and come back, because the sound has a tendency to remain on the eardrum for about 0.1 second. So it's only after this 0.1 second can you hear the next sound. So if you want to hear a proper echo, the minimum distance between the sound and the bounding surface or the reverberating surface has to be 70
Now,
But
if I hear some sounds which are very slow, so my
soft.
slow,
Uh,
slow. Is it a problem with my ear or the person is speaking low? How do I get to know?
It depends upon each person. So for example, some persons can hear the others very clearly and loudly. Maybe some other persons may have some kind of a sound. Now, when you're talking about loudness and softness of the sound, we've already seen regarding amplitude, right? What is this? This height of the crest from the median level is what is known as amplitude. The higher the amplitude, the louder is the sound. That means to say it has got more energy, it can throw out more energy. Okay? But if you're talking about a soft sound, the frequency will be the same, but this is a soft sound. Low, not frequency. Frequency is the same. See here, this is the frequency. Frequency is the same for both the waves. What I'm showing you is a low amplitude, and this is a high amplitude.
I thought that was going up and down.
Which one? This is the same thing. Look, that I showed you.
But no, how will I get to know there's a problem?
Then you will have to maybe you may have to see an ENT person, so he will be able to evaluate you. They do your auditory tests and they will be able to evaluate. Whether you are able to, some people cannot hear a very high frequency, some people may not be able to detect very low frequencies. They will be able to tell us.
Why does echo happen in like WhatsApp?
In WhatsApp?
Online, if someone's mic is on, echo us.
Yeah, maybe because of the transmission problems. Sometimes maybe your set itself is not programmed properly. See, when you're talking about transmission of sound, it's not only sound which has to be sent by your set, okay, but also the person who is receiving it. So there could be something wrong either with yours.
I think because the another person is turning his mic on. So both persons have their mic on. So when the first person says, the other person receives and again says. Because his mic is on.
So either way, you'll have to.
That's why we
monitor.
say that turn off your mic when.
Yeah. No, it maybe has to do with the programming. Did you understand now what is meant by amplitude? Amplitude, and if this is low amplitude, this is low amplitude. But did you notice that the frequency is the same for both of them? The frequency is the same. So high amplitude shows that there is a high amount of energy, and that is how you are able to. Come on, write down. What is reverberation? Reverberation. Okay, and how can it be reduced?
What, ma'am?
This is the question. What is reverberation?
The resistance of repeated
Okay. The repeated reflection. The repeated reflection of sound that results in the persistence of sound is called reverberation. That results in the persistence of sound. Persistence means what? That sound can keep on repeating, no? In the persistence of sound is called reverberation. क्या चल रहा है तेरा? निकाल रहा है, पेन निकाल रहा है, नया बुक आ गया, लास्ट क्लास से अभी नया बुक आ गया. How can you be so disorganized? What happens to the other book? You have the book or no? Then how come it is a new book? Huh? Coming to the 9th standard, I think you have to be a little more organized. Otherwise, you'll find it very tough in the 10th. Forget about 10th being, it's only because you're disorganized it becomes very difficult. Is that okay now, everyone? Okay. Then, first point, in order to reduce reverberation. So that is the second part of the question. How can we reduce it? In order to reduce reverberation in a big hall,
In a big hall.
auditorium, hall. Okay, it can be an auditorium or a big hall, marriage hall. It could be a hall where there's a, where the music recitals are taking place. Okay. To reduce reverberation, the roof and the walls of the auditorium. The roof and the walls of the auditorium are generally covered with sound absorbing
Material.
material.
The same is sofas and
Yeah.
that, right?
Yeah. Sound generally covered with sound absorbing material like compressed fiber board, compressed fiber board, FIBRE, board. Put a comma. Rough plaster,
Fiber.
compressed fiber board, BOARD, or rough plaster, or draperies. You know what is a drapery? These curtains, no? Velvet curtains, that is a drapery like this, but thick ones. So that will absorb. For what? Drapery. DRA. Drapes, no? It drapes. DRAPERIES. Next point also you write. Did you notice the cushions on the seat? They're all cushioned, they're thick cushion,
Yeah.
and it's usually made up of a. So it helps to absorb. So what we don't want is, suppose there's a sound, it should not hit, come back, hit there, come back, hit there, come back. That will cause a repeated echo. So that part of it has to be reduced. Second
What
one,
about the seats in the car?
not car, we are not talking
No,
car.
what are they then?
Just anything, we are not talking, we are talking about echo, right? How to reduce repeated echoes. Next one, the seat material is also selected. The seat material is also SEAT, seat.
Oh,
Seat material is also selected based on the sound absorbing properties. Okay. There's a sum now. Sum number 13. It's given there, I think it should be. Sound wave travels at a speed of 339 meters per second. Is it there? Okay. We are doing sum number 13 for that. We will do it, come on, whatever is there. Once we, yeah, here it is given on page number 79, sum number 14, question number 14. In the textbook, it is given as sum number 13. Okay, sound wave will travels with a speed of 339 meters per second. So what is 339? 339 meters per second. What does it tell us?
oh, frequency.
It is
Speed.
speed.
It's given there. It is the speed of sound. What is the alphabet that we are going to use for speed? V. Very good. Don't write S, and there's
V.
nothing else. S.
V.
It is V. It is the speed of sound, and we write it as V equals to, right? Next, if its wavelength is 1.5 centimeter, 1.5 centimeter, this is the
Wavelength.
so what is the symbol that we are going to use?
Lambda.
Lambda.
Okay, so this is the
Lambda.
and this is in centimeters. So what should we do?
Converting meters.
Into meters. How will you convert?
Into 10.
Into?
Oh, sorry, divided by 10.
How many centimeters make 1 meter? How many centimeters make
Right.
1 meter? Okay.
Right.
Divided by 100.
So it is 100 centimeters make a meter. So we want 1.5 centimeters to be converted into meter. What will you do? Divide or multiply?
0.015.
Yeah, divided by. Okay, so it is 1.5 divided by 100, so many meters. Okay. Then question is to find RTF is what required to find. This is what we have to find. What is the frequency? For frequency, what will we write? What is the symbol?
V. Nine.
It's the Teda wala. It's called nu. Okay. So which formula shall we use? I'll give you formulas. Come on, look at you. 1 or 2 seconds. Speed is equal to
Frequency of wavelength.
Speed equal to distance upon time.
wait here, but there's no distance, there's no time here.
Wavelength.
Speed into time.
Wavelength upon frequency.
Not upon, it is in wavelength times frequency. So speed is equal to wavelength times frequency.
Now what is RT?
RTF is required to find wavelength times frequency. So now you substitute the values and tell me. Don't look at your books, try to do it without looking at it. What should we find now? Frequency, correct? So if you want to find out frequency, what will we do? It is speed upon
It's a limited frequency.
how will you keep this? You can also write it as 1.5 divided by 100. You can also write 1.5 10 raised to power of 2. Correct? You can keep it that way also. So here, correct? Speed we already know. This is the speed. So it is 339 divided by this, which is 1.5 upon 10 raised to power of 2. So you can also write it as 10 raised to power of 2. This will be minus 1. It will go up, it will become 2. Shift the decimal.
How it works on energy.
How much is that?
22.6 upon 100.
Upon 100 or 10, 100 to the power of minus 2. This will come up from the denominator. This is divided by 2. So this is how much? Times 10 raised to power of 2. So you get it as 226 times 10 raised to power of 2. And since we are finding out frequency, this is going to be in hertz. You will get this value. Do.
2.6 into 10 minutes.
226 point.
2.6
Yeah.
into 10 raised to.
I think that's
Ah,
nothing
yeah,
wrong with the
that's
question.
2.26.
226.
2 to 6.
Then it's part of 2. So that is 2 more zeros. So what is our range of hearing from 20 hertz to 20,000 hertz? Okay. So how much is our answer? It is 226. Is it 2.6?
No.
It is 226.
Yeah.
Into 10 yes.
And 2 more
Because
zeros. Okay, 2 more zeros.
Yeah.
So now 1, 2, 3.
You can't hear.
Can we hear this?
What if we hear into depth or something?
I think you can't hear. Basically, our ears are designed in such a way that they can pick up only so much. So this is more than this 20,000 hertz. So you cannot hear this.
Now that does that mean external auditory canal can press?
No, it is basically it is because of the electrical signals. So what is happening here is the electrical signals. The mechanical vibration has to get converted into electrical signals, and that is sent to the brain. So that part of it is not developed in human beings. Whereas in man, in dogs, animals, okay, that is very.
Bats.
So we have got ultrasound, which they can also pick up. Have you written this? Therefore, write down. Therefore, this sound is more than 20,000 hertz, and therefore it cannot be picked up by the human ear. Okay. Let me see what else is there in your note. Okay, we have the other one. A stone is dropped from the top. See your question number 13. You want the book? Okay. Read the question carefully. Okay. Thank you. Now let us assume that this is a stone. Okay. What is given to us? A stone is dropped from the top of a tower, 500 meter high, into a pond of water. Okay. This is the tower, and we are dropping the stone, and it is falling down. There is a pond of water at the base of the tower. Okay. When is the splash heard at the top? So they want to find out how much time will that be.
8 minutes.
13, 14 something. Okay. So they're asking you how much time does the sound take to reach the ear of a person who's standing on top of the tower. G is given as 10 meters per second square per second.
Meter per second.
And the speed of sound, you have to take it as 340 meters. Okay, you what to do. So let's draw a picture for us to understand. Let us say this is the tower or whatever it is. Person is standing here, there is water here. Right? We are dropping a stone. Have they given anything regarding what is the height, what is the distance from here, what is the height of the tower? 500 meters. So 500 meter is the distance. Correct? Then what else is given? G is given, speed of sound is given. Okay, what is given? Height of tower. Come on, take it down. 500 meters.
Speed of sound. 340 meters per second square.
Not second square, meters per second. Okay, and value of G we have to take it as 10 meters per second square. What can we do? Can we find out T? How long does the stone take to drop from here to here? What is the first law, second law, third law? First law is
Again, the second law.
very good. Second law is what?
Because S is equal to UT plus half GT square.
Very good. So S is equal to UT plus half AT square. Now A has become G.
GT
G because now it is because of the acceleration due to gravity. Correct?
Ma'am, and we have chosen the second one because we don't know V.
Correct. We do not. So now what is here? Do we know U? What is
Zero.
U? It is the
Zero.
initial velocity. It is zero
Zero.
because it's still held in the air. So from this you can make out that it is 0 meters per second. Okay, so this part of it will become 0. So plus half. Okay, G 10 meters per second and T square. So find out T. S we already know this is equal to 500. Calculate this. Find out T.
Ten.
Correct. You got it? This will cancel out 5. It will become 5t square. You have to find out t square. So 5 will go on the other side. So it will become 500 divided by 5, which is 100. So 100 is equal to t square. Therefore, t is equal to root of 100 is how much? 10.
10.
Come on, do it. Yeah, yeah. Yeah. This is equal to how much? This is how much? Not 340. Where did you get 340 now? Who wants you to write 340? Over there. Yeah, that is, we have not yet come to that part of it. GT square. I'm using this formula now.
वो given दिया है ना इसलिए.
This is what we are using now. I've written the values also. G is how much? We have to find out T now. Where is L? Where is the speed of sound here? How much did you get? No. Come on, do. Cancel it and write 5. 10 and 5, 2 is 5. Is equal to 5t square. तो अभी क्या 5 इधर आ गया. 500 divided by 5 is how much? 5 will come on this side.
They divided by 5 is always 100 problem.
Yeah. Okay, now this is not the end of the sum. Okay, so the time taken for the stone to reach the pond below, we have got it as 10 seconds. Okay, it has taken from here to here, it has taken 10 seconds. But the man is standing on top of the tower. Correct? So when the stone falls in the river, there will be a splash and the sound has to come up. So we have to calculate that time also. So what formula?
T.
Distance is equal to? Speed is equal to? 10. So the second part of it, speed is equal to distance upon time. Okay? So now we have to find out time. So speed into distance. Time will go here, speed will come there. So distance is equal to how much? Distance divided by speed. Do that. This is your part B. That means we are finding out what time.
So
This is from here to here. This is part A. Part A we have already found that it is taken 10 seconds. Sorry?
We will take time as 20 seconds because
No.
10 seconds.
Distance we know 500. Distance is 500.
500. Yes.
Speed of sound W is
340.
340. Chalo karo. Time T, this is 500. Speed is equal to 340 meters per second. Okay. So meter and meter will get cancelled out.
Yeah.
Second will go on the top. So your answer will be in so many seconds.
Earphones are taken.
58 divided by 34.
16.
25 divided by 17. Ah, 34. 2 times single.
70. 70. 60.
There, 1 point.
And 1.4 something.
Very good. Correct. 1.47.
1.4,
7 कैसे
हाँ,
आया?
7.
17 से 1.9.
1.4.
फिर भी 10 मिला. हाँ.
1.4.
1.4 से.
Correct. So you will get the answer as 1.47. Okay? That means this is the time taken for the sound to reach the person who is standing here. Okay? But the time taken for the stone to fall down is 10 seconds.
then 10 plus 1.4.
Correct. So the total time is add them both. So therefore the total time taken, we are going to add up A and B. How much is it?
Eleven by 2.
A plus B.
4, 7.
6.
This is there or not? This is 4, 7.
11.4.
4, 7. 40. So दोनों का पूरा 4, 7. Except over the end.
Okay. 7.
34. There is
Question number 7. And all of you look at your question, I'll give you the book. Okay. A person, look at the question number 7.
78.
A person having a hearing range from 20 hertz to 20,000 hertz. What's it, son? Okay, or 20 kilohertz is given, so that means it is 20,000 hertz. Okay, K is given. What are the typical wavelength of sound waves in air corresponding to these two frequencies? What should we find? What is the typical wavelength? What should we find out? We should find out the wavelength. Frequency is given. We have to find out the wavelength. Okay, and take the speed of sound as 344. So they have already given us this part. Can we do this? Can do or no? Why everybody is very silent?
this one.
Let's write down the data. First you write down the data, then you will understand. So this is your question number 6 from the textbook.
I'm 7.
In your UP, I think it's a 7. Yeah. Here from the textbook, in the textbook it is 6. So you are having two frequency. One is 20 hertz and the other one is 20 kilohertz. Okay? I'll put it as A and B so that you understand. So this kilo means what? 20 into 1000 hertz. So these are the two frequencies which are given. That means the lower end of the frequency which we can hear and the higher end. What are the typical wavelength of sound waves in the air corresponding to these frequencies? What else is given to us? Speed of sound is given. And they have asked us to take it as 344 meters per second. Okay. Now required to find what should we find is the wavelength for this and for this. Okay. So what is the formula now? Which formula shall we
V
use?
upon
frequency upon wavelength.
Speed is equal to, remember only one. What is speed? Speed is equal to what? Wavelength into frequency. Correct? Now we have to find out the wavelength. So this is what we have to find out, which is nothing but speed. Speed is v. Okay? So which is equal to speed divided by frequency. Okay? So I have to find out for A, I'll find out the wavelength. Speed is 344 meters per second. And the frequency here is 20 hertz. How much is that? And for the second one, wavelength is 344 divided by 20,000 hertz. And this is meters per second in both the cases. What will be the unit for wavelength? Length. You're mentioning length, meter. It gets cancelled out. Did you see that? Meters per second and hertz is 1 upon second. So by second and second will get cancelled out and m is 1.
17.2.
How quickly you did? Do. Basically, what does it tell us? This 0, you just keep it aside. It is 344 divided by 2.
Yes.
So, got it?
Yes.
How much?
17.
Do for the next one. There are 3 more zeros. So you can write it as 10 raised to the power of minus 3, minus 4. Correct.
Zero point zero one seven.
Instead of putting it only, you can also shift your zeros and write it appropriately. So here you got it as 17.2, no?
Yes.
For the first one,
Yes.
17.2. Right? Now here how many zeros are extra? These 3 zeros are extra. Okay, so you can also write it as 10 raised to the power of minus, this is raised to the power of 3. When it comes here, the same answer, 17.2, you can write it as 10 raised to the power of minus 3. Did you get it? Okay. Next question. Come on, this is something that you have to write. Why is sound wave called longitudinal wave? Have I given you this question? Just look, see. Transverse wave, longitudinal wave. You can't give it.
No.
Of course I have.
Why is longitudinal?
Why is sound a longitudinal wave?
No.
Okay, come on, right.
नहीं है ना?
Why is sound called a longitudinal wave?
No, it's
Okay, come on, write down. In the longitudinal wave, write the answer. The individual particles of the medium move in a direction. How is it moving? In which direction?
straight.
Don't say straight. Straight can be like this, it can also be like this. Then
Linear.
this is also linear, this is also linear. In which direction?
Wait, something with R.
Left, right.
Left action.
So they just move a
ऊपर
little and
नीचे, नहीं,
then
कुछ
they keep bouncing.
Come in. Give me the correct one. How is the sound propagated? In this way. How is the vibration taking place? In the same way. So
Parallel.
So it is parallel to the propagation. चलो लिखो.
Uh,
They move in a direction parallel to
Particles of a medium.
particles of a medium move in a direction parallel to the direction of
Vibration.
propagation of sound. Okay. Next line write down. The particles do not move. Particles do not move from place to place. But oscillate. You know spelling of oscillate? O-S-C-I. Oscillate back and forth.
What is the meaning of
Oscillate is moving like this. O-S-C-I. Yeah. Pendulum is also oscillation.
OC?
O-S-C-I-L-L-A-T. Oscillate back and forth about the position of rest.
About the position.
Position of rest. So what are these mean? What are these particles which are vibrating? What particles are moving? Sound is air particles. Very good. So it is the particles in the air which are all vibrating about their mean position. Got it? Okay. Let's look at the other question. Will you learn up all these things? Frequency, pitch, loudness, all those things are very, very important. Sure. Put a tick mark for all these. You might better write it in your notebook, otherwise you will forget. See, you have not even done your homework. One simple thing I gave it to you. Sure. And shall we do one sum about echo? Sure. Right? Alright, come on. This is your question number 12 given on page number 18. One sum about echo. An echo is returned in 3 seconds. Question number 12. Read better. That's not
Page number 1.
80.
An echo is returned in 3 seconds. What is the distance of the reflecting surface from the source?
Speed is given
342.
340. Did you understand? Yeah. Suppose a person is shouting. He is hearing the echo after 3 seconds. Remember, he is hearing it after 3 seconds. So what is the time for the sound to reach that point?
1.5.
Okay. So that means whatever they have given you 3 seconds, 5 seconds, that has to be divided by half. Then what else have they given you? Speed. What is the speed given?
3.4.
Come on, write up. That's sum about echo. Okay, person is here and this is the. So for the sound to go and come back, how much time? Total time, how much? How much they have given?
1.93.
3. So total time they have given as 3. Correct? So time only for one direction. And obviously it is 1.5 second. Okay. What else is given? Speed of sound is given. How much? 344? Yeah, 42 or 44?
42.
42.
Why not speed of sound and total time 3 seconds? Like you should multiply with
You missed a class.
what? No,
You have experienced.
no, like
See what happens. What happens? What happens in an echo? Suppose a person is shouting. Sound has to hit that surface and it has to come back. Okay. Now what are we talking? We are talking only the distance between the person and the obstacle. So if we take complete 3 seconds, that means you have to take double the distance. We don't want double the distance. We want only this part now. So how much is the time here? Time we have to take only 1.5 seconds. For the echo, it is 3. Did you understand what I am saying?
The echo came back and
Came back. So it is going and coming, total is 3. So we really want only one distance. So that is 1.5. So the same thing we do. What is speed? What is which formula we
Distance
do?
upon time.
Do the same formula required to find is the distance. Okay. Formula you will use. Speed is equal to distance upon time. Therefore, distance you have to do speed into time.
I was saying the
Ah.
total time is 3 seconds, so I don't just multiply it with speed of sound and then I will do half of that.
That's the same answer. Going there. You can do that. No problem. What I have done is I have divided by 2 in the first step itself. What you are doing is do the entire thing and then divide by 2. You answer.
5 and 3.
I have to multiply by 3.
क्या
5 and 3.
यहाँ पे
You can multiply the whole thing into 3 and then divide by 2. Either which way you can do that.
Number 3 plus 2.
Okay, write down this.
3
Some, how much?
5
What will be? What are we
Meters.
finding out? Distance.
Yeah.
Distance is a meter. Okay. Write down a few. What is amplitude? Okay, tell me.
Height.
Height or sound? You write height. That's your definition. So what will you write?
amplitude is volume.
What is this?
Amplitude.
Correct. So height of what? Height of the sound wave, the maximum height of the sound wave from the mean position. Come on, write down. Amplitude. The maximum displacement of the particle. Which particle are we talking about?
Vibration.
Air. Particle of the air. Okay, maximum displacement of a particle from its mean position.
Ours not very big.
From its
Mean position. What is the mean position? That's the
Initial.
optimum position. Yeah. On either side is called the amplitude of the wave. On either side is called the amplitude of the. What can you find out from amplitude? Is it the pitch or is it the loud
Frequency.
or is it the loudness of the sound? Loudness. Come on, write on the next point. The loudness or softness of the sound.
amplitude.
The loudness or softness of a sound is determined by its amplitude.
What was pitch?
Tell me now, what is the unit of amplitude?
Meter.
How come?
Height. Meter.
Right. It is the distance, right? It is the displacement. So it is in meters.
So what is pitch?
Right? In next one. Frequency. What is frequency?
The number of total oscillations in unit time.
Very good. Okay, the number of waves that are passing through a particular spot in unit time. Right on frequency. The number of vibrations of a particle per second is called the frequency. What is the unit? SI unit is what? Hertz. Hertz. Okay, that is to honor the scientist. HERTZ. Come on, write down. SI unit of frequency
RTZ.
or HZ. Short form is HZ. You still pronounce it as Z or Z. Z. Gen Z. No? No, Gen Z. Yeah, Gen Zs. Okay. So did you write SI unit of Hertz is frequency is Hertz? Okay. Then I want you to also write down this. 1 Hertz is the frequency. When you say it is 1 Hertz, what does it mean? It means 1 Hertz is the frequency if the waves are generated at the rate of 1 Hertz का मतलब क्या है? In 1 second, 1 wave is generated. That's all. Understand?
1 second.
Yeah, in 1 second. If I say 50 Hertz, what does it mean? 50 waves are produced in 1 second. 50. If I say 1 Hertz, what does it mean? Only 1 wave is produced in 1 second. That's just an example. Did you write? 1 Hertz means that 1 wave is produced in a second at the rate of 1 wave per second. Okay, now write down pitch. Suppose you go to a recital or you're listening to some sound. You're hearing the flute and the violin. Okay? It has got a different pitch, isn't it? So basically this pitch is, come on, write down. How the brain interprets the frequency of a sound is called the pitch. How the brain interprets the frequency of the sound is called the pitch. Okay. Then write on this point. The faster the vibration, the higher is the pitch. Do you understand what I'm saying? Look at this diagram. Look at this diagram. High pitch and this is a low pitch. Greater the number of vibrations, this is a high pitch. That is nothing but frequency. So your pitch is related to the frequency.
So higher the frequency.
And so higher frequency is obviously a higher pitch. You must have read, Akbar, Bilber and all that stories in the olden days. People with very high pitch, they were able to break glass. You know it's possible because it reaches a resonance and with that high pitch they are able to crack the glass.
How does the glass crack?
How does it crack? Because the frequency matches and it causes resonance. You will not be able to reach that high frequency. Now I'm not talking about loud and soft. Did you understand the difference between loud and soft? Loud and soft is because of amplitude, but now I'm talking about frequency, how fast that waves, how fast you can produce. So that is your frequency. Got it? Next one. Probably the last one. Okay, go. I've given you frequency, amplitude is done. Now the wavelength. Last one is the wavelength. Tell me what is wavelength? Wavelength is like this. So क्या हुआ? Amplitude नहीं है. Wavelength.
The distance between the two crust and the two.
Either between the two crests or between the two troughs. Okay, come on, write down. Wavelength. How will you write? What is the symbol? Lambda. Isn't it? Lambda.
उल्टा है
Ulta y. The distance traveled by a wave.
What is it called?
Lambda.
Lambda. That is your Greek alphabet. The distance traveled by a wave in one complete oscillation, one complete oscillation of a particle is called the wavelength. So what is it equal to? It is equal to the distance between two crests or even two troughs. This is the crest, this is the crest. So the distance between two crests. Right up. The distance between two consecutive crests or trough. Yes. Or trough. This is what is known as trough. Why did we use the word consecutive? One after the other, not between the one and the 10th one. Right? What is the unit? SI unit? SI unit, how do we measure?
Distance.
We are measuring the measure. That is wavelength. Write down homework. Right? Just only write down. I'm not asking you to solve. That's all, no? Come on, write. Yeah. Write it down. When will it start? Has it started? This lesson has started with the school?
No.
Not yet.
It's for P3 for chorus line.
Okay. Anyway, you will have all the notes in your
PT.
okay. So you just write down. Please solve. Write down homework. MCQ is there. You have got your fill in the blanks. Okay. Please do all the sums from there. Right. All the best. Do well. See you next year.
Next year. Next year, 19.
You might not come.
Yes. Yeah,
You will not come.
I think so.
Still not sure.
Not sure. Okay.
Yes.
Okay. Then.
Next one for
But see you soon.
See you soon. Yes. All the best. Do well. All of you. And be regular.
me.
Ah.
I'm not regular.
You are too irregular, don't you agree?
Oh, ये भी ना बोल.
चिप्स किधर गया मेरा?
अरे बोल किधर गया?
एक पार्ट में से आधा
हैं? कौन पागल?
तेरा कंट्रोल कर रहा है
मैंने कब पागल चूती है?
तेरे तेरा आवाज है
अरे वो ना निकाल.
नाम भी है तेरा मैं सुना ये
मुझे नहीं दिया.
मैं सुना ये एंडर आर्नोल्ड में एक दूसरे को देखने तक के दूसरा वाला था
क्या क्या
महंगा है
कैसा स्टॉप हो
अरे है क्या आपका
मेरा
So guys.
5 minutes